Hi everyone. So in this video we will start studying about scattering parameters. Now this is a very vast topic, okay? If you go to masters, if you study microwave engineering, if you go into RF field, so there you will study this particular topic in a very in-depth manner. Like for one whole semester you will be studying about scattering parameter. But as of now we will study only whatever that is required. So let's start our video. We will start studying about scattering parameter. So what do we know? We know different kind of parameters: Z parameter, Y parameter, G parameter, H parameter, ABCD parameter. These parameters we know. There are a lot of parameters. So what do we used to do? There would be a two-port network. We used to call port 1. This we used to call port 2. So what we used to do? This is our network. This is our one of the two-port network. What we used to do? We used to apply some voltage V1 here and get current I1 out of it, and then we used to apply voltage V2 here and get current I2 out of it. And with respect to V1, I1, V2, I2, we used to define our Z parameters. So for Z parameters, like for different parameters, we used to define different things. But for Z parameter, how we used to define? V1 is equals to Z11 I1 plus Z12 I2. V2 equals to Z21 I1 plus Z21 I2. Sorry, Z22 I2. So for different parameters, you used to define in different manner. Then we used to find the value of Z11, Z12, Z21, Z22. How we used to find? Z11 would be equals to V1 by I1 when I2 is 0. That means when this particular port is open circuited. So V1 by I1 will be equals to Z11. And how we used to find Z21? V2 by I1 when I2 is equals to 0. So in these manner, we used to find these parameters. So this is what we call as parameters, like any parameters of the network. So this is a two-port network whose Z parameter is defined. If I apply some V1 I1 here, V2 I2 here, then this would be the relation. Same thing we are going to do with the scattering parameter. But now this we will come back to this slide. But let's understand scattering parameter. So this is a two-port network whose scattering parameters are defined: S11, S12, S21, S22. So in the previous part, in Z parameter, what we were doing, we were applying V1 here and getting I1 out of it. Here, what we will do, we will generate a V1 plus voltage. Not voltage, this is a wave. We are giving it a V1 plus wave. So some part will be reflected back and some part will be transmitted. So if I give a V1 plus wave, then this part is reflected back and this part is transmitted. Now I can give V2 plus wave as well. On this port I gave V1 plus wave. V1 minus was reflected back and V2 minus was transmitted. Now I am giving V2 plus wave at this port. I am giving V2 plus wave at this port. So some part will be reflected back, which is this one only, and some part will be transmitted, which is this one. Are you getting this point? What did I do? There was a two-port network. Okay. I am giving some V1 plus voltage wave here. V1 plus voltage wave, or you can say I am giving some power. V1 plus power. Power is not V1 plus, certainly power is V1 plus whole square divided by 2 Z naught, which we studied in last lecture only. So that power we are giving. Okay. And some part will be reflected back, V1 minus will be reflected back and V2 minus is transmitted. Or what I could have done, that from this side of port, this is your port 1, this is your port 1 and this is your port 2. So at port 2 what I could have given, from port 2 as well I could have given V2 plus wave, then V2 minus will be reflected back and V1 minus will be transmitted. Is that clear to you? So V1 plus and V2 plus are the incident wave at port 1 and port 2 respectively. And V1 minus and V2 minus are the reflected wave at port 1 and port 2 respectively. Or you can say V2 minus is the transmitted wave at port 2 and V1 minus is the transmitted wave at port 1. Is this clear to you? Right? These names you don't need to mug up, but I am just telling what we are doing. Now what will here this was your two-port network. So these were simple wire, no? Like let's just say this was your two-port network. This was your two-port network. And then you used to, this was your two-port network. Some R1, R2 and R3 was there. Then you used to extend it. Here you used to apply V1 and get I1 out of it. Then you used to apply V2 here and get I2 out of it. Then you would find the relation and you would define your Z parameters. So you just used to extend it with some wire. Here when we are extending with transmission line. So this is my transmission line. Okay. So this is my transmission line 1 I am saying, this is my transmission line 2 I am saying. So transmission line 1, then there is a network, then transmission line 2. Are you getting this point? Transmission line 1, network transmission line 2. So transmission line 1 and transmission line 2 are connected by a two-port network whose S parameter are defined. So what I am doing on transmission line 1, I am sending V1 plus wave, V1 minus is transmitted, sorry, V1 minus is reflected back and V2 minus is transmitted. And on transmission line 2, I am giving V2 plus wave where V2 minus is reflected back and V1 minus is transmitted. Is that clear? And how will I define my S parameters now? So similarly here, how we used to define V1 equals to Z11 I1. So in the same manner, what I'm going to define is that this you need to keep in mind. V1 minus is equals to S11 V1 plus S12 V2 plus, and V2 minus is equals to S21 V1 plus S22 V2 plus. So this is how it is defined. Okay, so this you need to keep in mind always, otherwise you will not be able to solve the problem. Now our target would be to find S11, S12, S21, S22. So what do you think, what will be your S11? So for finding S11, we need to put V2 plus equals to 0. So S11 will be equals to V1 minus divided by V1 plus, considering V2 plus is equals to 0. What will be your S21? So for finding S21, you need to put V2 plus equals to 0. So S21 would be equals to V2 minus divided by V1 plus, considering V2 plus is equals to 0. What would be your S12? So for S12, you need to put V1 plus equals to 0. S12. So that would be equals to V1 minus divided by V2 plus when V1 plus is equals to 0. And what is your S22? So S22 is V2 minus divided by V2 plus when V1 plus is equals to 0. Okay, so till now the things are clear. Two transmission line, in between there is a network. V1 plus I am sending, V1 minus is being reflected back. V2 minus I am sending, V2 minus is being reflected back. Now I need to find these parameters. How will I find that? So let's check that out. So first I am calculating S11 and S21. S11 and S21. That means I need to put V2 plus equals to 0. V2 plus equals to 0. So what I am going to do, this is my two port. This was port 1. This was port 1. This was port 2. This was transmission line 1. And this was transmission line 2. Okay, one more thing I forgot to tell here. Before coming into this part, one more thing I want to tell here. So just at the end of the transmission line, here I am writing V1 plus here. Okay. So when you solve the problems of transmission line, just at the transmission line, you will always assume V1 potential. Just at the end of the transmission line. End of the transmission line 1, I am assuming V1 potential. And at the end of the transmission line 2, I am assuming my V2 potential. Now this V1 potential is equals to V1 minus plus V1 plus. Okay. And V2 potential is equals to V2 minus plus V2 plus. So will you be able to keep this thing in your mind? Now sir, why this S parameter came, what is the meaning of this S parameter, doesn't matter. Okay, if you need to study in depth, then it will take a lot of time. You can study in your masters. Here with respect to gate examination, I need to teach within 2 hours. So what I told you to remember, first I compared it with Z parameter. V1 I am sending, I1 we are getting, V2 I am sending, I2 we are getting. Then this is your two-port network which is connecting two transmission line. On one transmission line you are sending V1 plus and reflected back V1 minus. Here you are sending V2 plus and reflected back V2 minus. Two-port network is there. Now how S11, S12, S21 and S22 are defined, that also I told you. V1 minus is equals to S11 V1 plus S12 V2 plus. And V2 minus is equals to S21 V1 plus S22 V2 plus. Okay. Now one more thing, just at the end of the transmission line you will assume some V1 potential, and just at the end of the transmission line you will assume some V2 potential, and that V1 potential is equals to V1 minus plus V1 plus, and this V2 potential is equals to V2 minus plus V2 plus. Okay. So whatever the incident and reflected waves are there, just a combination of both of them is equals to V2, and incident and reflected combination of both of them is equals to V1. These will help us in solving the problems in an easier manner. Otherwise, this particular concept becomes very complex and student will just mug up the method. But we are not going to mug up the method. Now, what we are going to do, we need to calculate S11 and S21. Okay. So for that, we need to keep V2 plus equals to 0. We need to keep V2 plus equals to 0. So what was our V2 plus and what was our V1 plus? So what was our V1 plus? So we were sending V1 plus here, and V1 minus was reflected back. Now this doesn't matter that sir, here you are making V1 plus downward and V1 minus upward. So this doesn't matter, anywhere you can make. This is just a wave. So V1 plus is being sent back and V1 minus is being reflected back. Here I could have made V1 plus. The direction matter, that V1 plus is the incident and V1 minus is the reflected one. And here V2 plus is the incident and V2 minus is the reflected one. Now what do? I will connect a load here. What I need to do, I need to keep V2 plus equals to 0. So for that what I am doing, I am connecting a load. This load is ZL, okay, and this is my transmission line which is having an intrinsic impedance of Z0, and this is also having an intrinsic impedance of Z0, okay, or I can say this is having Z02 and this is having Z01. Now for this load, okay, for load ZL, which is your incident wave and which is your reflected wave? You tell me. For load ZL, for load ZL, for load ZL, what is your incident wave and what is your reflected wave? V2 minus is the incident wave, right? Because on the load V2 minus is coming and V2 plus is being reflected back. Regarding the port, what we were doing when we were studying about the port. So in the port, these two were the transmission line, and from here we were applying something. From here we were applying something. So what did we apply? V1 plus we applied, V1 minus was reflected back. Here V2 plus we applied and V2 minus was reflected back. Now what this load will think? If I connect a load here, what this load will think? That V2 minus is my incident wave across this load and V2 plus is the reflected wave. So V2 minus is the incident wave and V2 plus is the reflected wave. Now you tell me what should be the value of ZL? What should be the value of ZL to make V2 plus equals to 0? Think about it. What should be the value of ZL to make V2 plus equals to 0? That means there should be no reflection. If there should be no reflection, that means load should be matched. That means ZL value should be equals to Z0, if you remember it, or let me revise it to you. So if your ZL is equals to Z0, then what will be your gamma? Gamma is always equals to ZL minus Z0 upon ZL plus Z0 e to the power minus 2 gamma y, right? So if ZL is equals to Z0, then always reflection coefficient at any point on transmission line will be equals to 0. At what condition? When ZL is equals to Z0. And when ZL is equals to Z0, then what is your Zin? What is your Zin? Zin is Z0 into ZL plus J Z0 tan beta L divided by Z0 upon J ZL tan beta L. Or at any point of transmission line, always you will see Z0 impedance. Why is that so? Because ZL is replaced with Z0. So this ZL is replaced with Z0. Now this and this term will get cancelled. So Zin is equals to Z0 only. Zin is equals to Z0. So your transmission line completely can be replaced with simple Z0 resistance. Along with that, there will be no reflections. So if you want V2 plus to be 0, for V2 plus to be 0, what we need to do? ZL should be equals to Z0. And this condition is known as matched load. What is this? This is your matched load. So if I need to calculate S11 and S21, my first task would be that I need to put V2 plus equals to 0. And if I need to put V2 plus equals to 0, that means from here reflection should be 0. So this ZL should be equals to Z02. This is having an impedance, this is having a characteristic impedance of Z02. So ZL should be equals to Z02. So that I will put. If I put that, then after that what I need to find? V1 minus divided by V1 plus. What do you think? What is your V1 minus divided by V1 plus? What is your V1 minus divided by V1 plus? That is the reflection coefficient here. Say yes or no. Incident wave and this is a reflected wave. So what will be the reflection coefficient here? What will be the reflection coefficient? That would be reflected wave divided by the incident wave. So this will be the reflection coefficient and that would be equals to S11. And what would be your S22? S21, sorry, not S22. What will be your S21? So S21 will simply be V2 minus divided by V1 plus. So this I am calling as reflection coefficient. Reflection coefficient when port 2 is matched. Reflection coefficient at port 1 when port 2 is matched. Okay. Reflection coefficient at port 1 when port 2 is meshed. Is that clear to you? This is just the naming. Now what about this? V2 minus upon V1 plus. Can I call it as a transmission coefficient? Because what did I say? V1 plus is incident, V1 minus is reflected back, and V2 minus is transmitted. V1 plus is incident, V1 minus is reflected back, and V2 minus is transmitted. So can I call V2 minus divided by V1 plus as transmission coefficient? Yes. So transmission coefficient at port 2, it will be called at port 2. Actually, V1 plus is incident at port 1, but it is being transmitted at port 2, no? V2 minus is being transmitted at port 2. So this is known as transmission coefficient at port 2 when port 2 is meshed. Okay. Although the naming will not be used, but still we should know what do we call it. Reflection coefficient at port 1 when port 2 is meshed, that is V1 minus divided by V1 plus. Because this is the incident wave, this is the reflected wave. So reflected by incident. What about the transmission coefficient? Transmission coefficient is that V2 minus divided by V1 plus, but transmission coefficient at port 2. This will be known as transmission coefficient at port 2 because wave is transmitted at port 2 only. So transmission coefficient at port 2 when port 2 is meshed. This port 2 is meshed. Is that clear to you? So this is how we are going to find S11 and S21. What we need to do? We need to put V2 plus equals to 0. How will we put V2 plus equals to 0? We need to match the load. If we match the load, this is our transmission line. If we match the load, that means there will be no reflections. If there is no reflection, then it's all good for us. If there is no reflection, that means V2 plus is 0. Now my task would be only to find gamma in here. Okay, just to find gamma in here, and then V2 minus divided by V2 minus divided by V1 plus. So certainly we will see in a lot of example, we will solve 3 to 4 examples. There we will see how to find these calculations. Okay, so do not worry about that. But as of now, we are building up the concept. So what do you think? How will I find S22? So for S22, I need to put V1 plus equals to 0. So this is my transmission line 1, which is having Z01 intrinsic impedance, and this is having Z02 intrinsic impedance. So what I will replace this transmission line with? This is my port 1. I need to make V1 plus equals to 0. So this was the incident wave. This was the reflected wave. Here this was the incident wave. And this was the reflected wave. Now I need to put V1 plus equals to 0. That means I will be doing something at port 1. So at port 1, I will be replacing it with some impedance ZL. At port 1, I will be replacing my load with some impedance ZL. Now if this load is, for this load, what is V1 minus? V1 minus is the incident wave. For this load, V1 minus is the incident wave. For load ZL. And what is your V1 plus? V1 plus is the reflected wave. Okay. And if ZL is equals to Z01, if ZL is equals to Z01, what does that mean? There is no reflections. That means there will be no reflection, or you can say matched load, no reflections, or you can say V1 plus will be equals to 0. Right? Or you can call it matched load condition. Load is matched. Okay. So for V1 plus equals to 0, I need to put ZL equals to Z01. Then I can find if V1 plus is equals to 0, then what will be S22? If V1 plus is equals to 0, then S22 will be simply equals to V2 minus divided by V2 plus. And what do you think? What will be here? V2 minus divided by V2 plus. Here I need to find the reflection coefficient. Gamma, I was calling it as gamma in. Previously I was calling it a gamma in. Can I call it as gamma out? So that would be equals to my S22. So I am not naming it, you can name it. What you will name it? Reflection coefficient at port 2. Let's name it only. Reflection. Certainly we will solve the problems. When we solve the problems, it will be more clear to you. Okay. Do not worry about it. Reflection coefficient at port 2 when port 1 is meshed. And what is your S12? What I need to find S12? Yeah, S12 will be V1 minus upon V2 plus, right? Can I call it as a transmission coefficient? Because V2 plus will be incident, V2 minus will be reflected back, and V1 minus will be transmitted. So I can call it transmission coefficient at port 1. Transmission coefficient at port 1 when port 1 is meshed. Okay, so this is how we are going to do the calculation. Here you might not be understanding a lot of things, but once we solve the problems, you will understand. So now this is the first question, that this is your two-port network, which is a single series element, and these are two transmission lines. These are the ports. Both are having Z node impedance. This is a single network, which is your two-port network. This is your two-port network. So with respect to this, we will define S11, S12, S11, S12, S21, and S22. And these are the two transmission lines. This is your port 1, this is your port 2. Port 1, port 2, in between there is a network. So what it is saying, a load of Z equals to 50 ohm, forget about the value, is connected in series in a 2-wire transmission line of Z naught equals to 50 ohm, forget about the values. As shown, the port S parameter of the series element, the port S parameter, the two port S parameter, what I should have written, the two port S parameter of the series element. So this is my series element. There is transmission line 1, transmission line 2. What I am going to do, I am going to send V1 plus, V1 minus will be reflected back, and here I am going to send V2 plus, and V2 minus will be reflected back. Another important thing is, I will assume a voltage here V1, and I am assume a voltage here V2. Okay, so V1 is equals to V1 plus plus V1 minus, and V2 is equals to V2 plus plus V2 minus. And then I will define my S parameter in this manner. I hope this definition you will keep in mind. You will start by V1 minus, and here V1 minus, V2 minus you will pick S11 V1 plus plus S12 V2 plus, V2 minus would be equals to S21 V1 plus plus S22 V2 plus. Okay. Now let's start finding our parameters. So S11 and S21 we will find first. What we are going to find? S11 and S21. For that, what we need to do? We need to keep V2 plus equals to 0. And how would we keep V2 plus equals to 0? By matching the load. So what we are finding? First we are finding S11 and S21. That means if I am finding this, what does that mean? That I need to keep V2 plus equals to 0. And if I need to keep V2 plus equals to 0, that means port 2 is matched. Port 2 is matched. Okay. So here port 2 will be matched. So this will be your ZL, which will be replaced with Z naught. Okay. So this is your transmission line 2. This is your transmission line 2. Transmission line 2. Now what is my task? That I had sent V1 plus here, and V1 minus will be reflected back. So now what is my task? I need to find the reflection coefficient. So how will I find the reflection coefficient? So look, this is your transmission line 2, this was your transmission line 1. Now look at only this much portion. A transmission line having Z naught characteristic impedance and load is Z naught as well. So how you can replace this much of transmission line? This much of transmission line can be replaced with Z naught impedance. Say yes or no? Are you getting this point? What I am doing? Right? This much of transmission line here can be replaced with Z naught impedance. Z into is equals to Z naught. Right? Because what is the input impedance of this line? Z naught only. And where you are having V1, I told you at the end of the transmission line. That means at the beginning of the port you are assuming V1. So this is my V1. This is my V1. And at the end of the transmission line, here I am assuming my V2. Okay. So now this much will be replaced with the Z naught. So let's replace it. So this is the transmission line which will remain there as it is. This is the transmission line which will remain there as it is. Then there is Z impedance and now input impedance will be Z0. This will be Z0. Now what will be this potential? You have replaced your transmission line with Z0 impedance, but V2 is there as it is, no? This will be your V2, right? This is my V1, this is my Z, and this is my transmission line 1. This much is my transmission line 1 with Z0 characteristics impedance. Okay, now on this transmission line 1, you are having incident wave, that is V1 plus. So let's make it here only. On this transmission line, you are having incident wave V1 plus and reflected wave V1 minus. What you need to find? What you need to find? You need to find what is my S11. S11 is V1 minus divided by V1 plus. And what this is equals to? V1 minus divided by V1 plus. If you remember clearly, V1 minus divided by V1 plus, what that was equals to? Reflection coefficient at load. And what do you think, what is my load here? For this transmission line, for this particular transmission line, let me change the color. For this transmission line, what is the load? Load is Z plus Z0. Say yes or no. For this particular transmission line, what is the load? Load is Z plus Z0. ZL minus Z0. What is Z0? Z0 only. Divided by ZL plus Z0. Is that clear to you? So what you are getting? Z upon Z plus 2Z0. This is the value of S11. There you go. Again, I am repeating, very easy. If you go step by step, if you mess it up, then it will not be easy for you. It will be very difficult. So Z network element was there. This was your 2 port. 2 transmission line were there. Transmission line 1, transmission line 2. These 2 were acting as a port. V1 plus you send, V1 minus will be reflected back. V2 plus you send, V2 minus will be reflected back. You need to find S parameter. You defined the S parameter. One thing you know, just at the beginning of the port V1 potential, just at the beginning of the port 2 V2 potential is there. Then what did you do? You need to find S11 and S21. That means you need to put V2 plus equals to 0. If you need to put V2 plus equals to 0, that means there will be no reflections. No reflections by the load ZL. Here I will assume a load ZL. So if there is no reflection, that means this has to be matched load. If this has to be matched load, that means this has to be equals to Z0 impedance. If this has to be equals to Z0 impedance, then that means this transmission line can be replaced with complete Z0 impedance only, because input impedance of a transmission line having load equals to matched. If the load is matched, then input impedance is simply equals to Z0 only. So now I am replacing it with Z0. But one thing I am keeping sure, that this was your V1 and this was your V2 only, because this is the beginning of the transmission line which has been replaced with Z0. Okay. So now what I need to find? I need to find V1 minus divided by V1 plus, because what is my S11? S11 is V1 minus divided by V1 plus. And what is V1 minus divided by V1 plus? That is the reflection coefficient at load. What is that? ZL minus Z0 upon ZL plus Z0. Here what is acting as a load? This much is acting as a load. For this transmission line, what is the load? This is the load. So Z plus Z0 minus Z0 upon Z plus Z0 plus Z0. So what you are getting? This is your S11. Is there any confusion? Certainly no, there is no confusion at all. Now what do I need to find? I need to find S12. So what will be my S12? Let's take it to the next page. So I need to add a page now. So my S12 is V1 minus divided by V2 plus. So something with V2 I need to do. Is that clear to you? This is my S12. So let's not keep it here. Let's bring it back. Now let's bring back this diagram. So something between V1 and V2 I need to find some relation. Can I find some relation between V1 and V2 here? Can I say that my V2 is equals to V1 into Z0 upon Z plus Z0? Do you agree to this point? V2 is equals to V1. This was your V1 potential, this was your V2 potential. So V2 is equals to V1 into Z0 upon Z plus Z0. And what is your V2? V2 is your V2 plus V2 minus. And what is your V1? V1 is V1 plus V1 minus. Right? I told you here only that V1 is equal to V1 plus V1 minus, and V2 is equal to V2 plus V2 minus. Now let me know one thing. For finding S21, what you are assuming? Wait a second. What was your S1? Oh, sorry. We are finding S21. Really sorry. We are finding S21. Really sorry. We are finding S21. So that is V2 minus divided by V1 plus. What is your S21? S21 we are finding. S21 we are finding. V2 minus divided by V1 plus. So here what you are assuming that your V2 plus is equals to 0. What we are assuming that our V2 plus is equals to 0. So that means here V2 plus is equals to 0. That means V2 minus will be equals to V2. V2 will be equals to V2 minus only because V2 plus is equals to 0. This is equals to 0. So V2 is equals to V2 minus only. So here I can replace V2 as V2 minus. What is your V1? V1 is V1 plus plus V1 minus into Z naught upon Z plus Z naught. Now if I divide V1 plus on both of the side, what I can do? I can divide V1 plus on both of the side. So V2 minus divided by V1 plus. Why I am doing so? Because I need this expression. And then dividing V1 plus. So here 1 plus V1 minus divided by V1 plus into Z naught upon Z plus Z naught. What is this V2 minus divided by V1 plus? S21. And this we are getting, this V2 equals to V2 minus we got because V2 plus is equals to 0. V2 plus is equals to 0. V2 plus is equals to 0. We have put V2 plus equals to 0. Here V2 plus equals to 0 we have put. So that's why we were getting that. Now we just need to solve it. Do I know the value of V1 minus divided by V1 plus? Yes, certainly I know. V1 minus divided by V1 plus. This was equals to V1 minus divided by V1 plus. What is the value? Z upon Z plus 2Z naught. So Z upon Z plus 2Z naught. Z naught upon Z plus Z naught we are getting. Okay. So if we solve it from here we can solve S21. What we are getting? 2Z plus 2Z naught. 2Z plus 2Z naught upon Z plus 2Z naught into Z naught upon Z plus Z naught. So here 2 common I can take. So 2Z naught upon Z plus 2Z naught. This is your S21. Now two parameters are left. What all are those? Those are S12 and S22. Try doing it on your own. You will be able to do it. Believe me. This is not tough. As of now, it is looking tough. When we studied network analysis, then then at first glance you would have found two-port network as a tough topic. But now it is not tough. Okay, because you have enough practice. So certainly in this as well you need enough practice, and that certainly we will do. We will drill 3 to 4 examples. So enough practice we are going to do. But now you need to find S12 and S22 on your own. What you are going to do? You are going to keep V1 plus equals to 0. So I will take a break. You can again revisit it what we are doing. First V2 plus is equals to 0, then Z naught, then this is our input reflection coefficient, and then here V2 plus equals to 0 I put. Here I use the concept of network analysis that this is my V1, this is my V2. So simply potential divider I do. And if I do the potential divider, then V2 is equals to V2 minus only because V2 plus is already 0. And V1 is equals to V1 plus plus V1 minus. So I just need V2 minus divided by V1 plus. So from here we got the value. Okay, I need to pause the video. You try doing it on your own. What you need to find? You need to find S12 and S22. Then I will come back and we will start doing it. Okay, so let's start again now. I'm feeling better. Hopefully it will be better only. So V1 plus is incident here. V1 minus is reflected back here. V1 minus is reflected back here. V2 plus is incident here, and V2 minus is reflected back here. Now what do I need to find? What I am finding? I am finding S12 and S22. This is what we are finding. So for them, what we need to put? We need to put V1 plus equals to 0. If I need to put V1 plus equals to 0, that means this load should be matched. So this should be replaced with Z naught. Then this will be your V1 and this would be your V2 only. Right? At the beginning of the port, V1, V2. Now what is your V1 plus here? V1 plus is the reflected wave and V1 minus is the incident wave. So for V1 plus equals to 0, we are matching the load. If we are matching the load, then what will be your input impedance? Input impedance will be Z0 only. So from here, this much circuit can be replaced with Z0. So this is replaced with, same ditto analysis is there. This is replaced with Z0. This is your Z. This is your Z. And now this is your transmission line. Z0 and Z. And this is your transmission line 2, where V2 plus is the incident wave and V2 minus is the reflected wave. This is your V2, and here this is your V1, which is replaced with Z0 here. So this is your V1. So from here, what do I get to know? That what is my S22? S22 is V2 minus divided by V2 plus, which is your reflection coefficient only at load. Reflection coefficient at load, which what that is equals to ZL minus Z0 upon ZL plus Z0. So what is your ZL? ZL is Z0 plus Z, ZL minus Z0 upon ZL plus Z0. ZL minus Z0 upon ZL plus Z0. So S22 is equals to, this S22 is coming when V1 plus is equals to 0. So always this need to keep that V1 plus is equals to 0. So Z upon 2 Z0 plus Z. So this is your S22. Okay. And what else I can see? I can see that my V1 is equals to, not here, let's write it down here. V1 is equals to V2 into Z0 upon Z0 plus Z. Okay. What is your V1? V1 is V1 minus plus V1 plus. What is your V1? V1 is V1 minus plus V1 plus. But V1 plus is equals to 0 here. Here V1 plus is equals to 0. If V1 plus is equals to 0, that means V1 is equals to V1 minus only. Right? And what is your V2? V2 is equals to V2 minus plus V2 plus. Okay. And what we are finding? We are finding S12. S12 is equals to V1 minus divided by V2 plus. Which condition? When V1 plus is equals to 0. So my target is to find V1 minus divided by V2 plus. So V1 is equals to V1 minus, V2 is equals to V2 minus plus V2 plus into Z0 upon Z0 plus Z. So what I am going to divide with? I am going to divide with V2 plus. Why V2 plus? Because from here I am going to get the expression of S12. So if I divide with V2 plus, so this will be V2 plus divided by V2 plus, that would be 1, and this is your V2 minus divided by V2 plus into Z0 upon Z0 plus Z. What is this value? This value is S22. And what is this value? This value is S12. So S22 value we know, we will put this value, and S12 value we will get. So what value we will get? Same to this value, that is 2Z0 upon Z plus 2Z0. Okay. So there you go. This is your scattering parameter value. So what will be your scattering parameter? Your scattering parameter is defined as S11. What was your S11? S11 was Z upon Z plus 2Z0. Z upon Z plus 2Z0. What was your S22? Z upon Z plus 2Z0. What was your S12? S12 is 2Z0 upon Z plus 2Z0. And same goes for S21 as well, 2Z0 upon Z plus 2Z0. So this is your scattering parameters. Is that clear to you? Fine. So this is how you are going to find your scattering parameters. Very easy thing. Try doing it. Try doing this one now. Just in place of series element, now there is shunt element. So this is your two-port network now with respect to what you need to define your parameters. Okay, and this is your relation V1 minus is equals to S11 V1 plus S12 V2 plus, V2 minus is equals to S21 V1 plus S22 V2 plus. So what you are going to do? Again, you will send V1 plus, you will receive V1 minus, you are going to send V2 plus, you will receive V2 minus. Like some guys solve it with ABCD parameter. Now if you need to solve it with ABCD parameter, if you need to apply some stupid formulas, then why you are studying, right? So there is no meaning of solving it with ABCD parameter. Like if you just apply, keep on applying, like I have seen in a lot of notes, they will just teach some formula regarding the ABCD parameter, then they will say that first you find ABCD parameter, then you put the value of ABCD parameter in those formulas. it's not, we are not building engineers then, right? So we need to see the method, how we go with that. And where I will assume V1 plus, here I will assume V1 plus, and here I will assume V2, right? Is that clear to you? So what we are starting, first we need to find S11 and S21, S11 and S21. And guys, if you find our content on PrepFusion helpful, then share it, but pray for my health. Okay, I am getting very scared. Like I am getting tired very early. I'm not sure, and my health is not even improving. I'm not sure what else I need to do. My voice has gone down, right? And regular cough is there. I don't know, and like my head is spinning around. As of now, as well, the head is spinning around. I'm seeing that this screen is like toggling. Okay, so pray for my health, guys. Okay, so yeah, what I need to do, V2 plus I need to keep equals to 0. Here, this will be your V2 plus and this will be your V2 minus. But if you need to keep V2 plus equals to 0, then I need to match the load. Also share it, because if we share, we get enough subscriber and good motivation as well, and along with that, it will be financially good for us. Okay, certainly if we are financially good, then we feel good. Why we are studying? To be financially stable. And why I am teaching? Because I have the passion. Certainly I have the passion, not like other people who just say they have the passion. Certainly I have the passion. Along with that, certainly it gives me money as well. Yeah, so share it with your friends as well. Okay, so where was your V1? This was your V1. And where was your V2? This was your V2. Can you see one thing here? V1 is equal to V2, right? Now, but what I will be replacing with this transmission line, I will be replacing with Z naught. So this is my one of the transmission line. This is my one of the transmission line which is having Z naught impedance. It was having Z load, or you can say this was your two-port network. Now this transmission line will be replaced with Z naught impedance, because input impedance will be Z naught, right? Because load is matched and this impedance is also Z naught, so input impedance will also be Z naught, and this potential will be equals to V2 and this potential was equals to V1. So here what I am going to find, first I am going to find S11. What is your S11? S11 is simply V1 minus divided by V1 plus. What this is equals to? Certainly when V2 plus is equals to 0. What this is equals to? This is the reflection coefficient at load. What that is equals to? ZL minus Z naught upon ZL plus Z naught. Now what is ZL here? ZL is here, ZL is Z parallel with Z naught. That is equals to Z into Z naught upon Z plus Z naught, ZL minus Z naught upon ZL plus Z naught. Okay, this is your reflection coefficient, but I need to keep it down, otherwise it doesn't look good. So now it looks good, right? So what I can do is that I can keep Z naught as common and then cancel it up. So what I am getting, if I take Z naught as common and cancel it up, what I am getting is that Z minus Z minus Z. So here I am getting minus Z naught, and then downward I am getting 2Z plus Z naught. Okay, this is your S11. Let me check it again. Let me check I can check the answer as well. Yeah, same. Like I was just checking if there is any calculation mistake, but no. Z naught is getting answer minus Z naught upon 2Z plus Z naught. Okay, so this is your S11. Very simple mathematics we are doing, nothing else. Along with that, what else I can see here, that what I need to find now, I need to find S21. What is your S21? S21 is simply V2 minus divided by V1 plus when your V2 plus is 0. So here I can directly see that my V1 is equals to V2. What is V1 equals to? V1 is equals to V1 plus V1 minus, and what is V2 equals to? V2 minus plus V2 plus, but V2 plus is equals to 0 only. V2 plus is here, it should be V2 plus, but that is equals to 0, so that I am not writing. Now I need to find V2 minus divided by V1 plus, so I am going to divide by V1 plus. So if I divide by V1 plus, what I am going to get? 1, and here I am going to get V1 minus divided by V1 plus is equals to V2 minus divided by V1 plus. What is V2 minus divided by V1 plus? That is S21. That is S21. And what is 1 plus V1 minus divided by V1 plus? What is V1 minus divided by V1 plus? This was your V1 minus divided by V1 plus. That was equals to minus Z naught upon 2Z plus Z naught. So what you are getting? 2Z upon 2Z plus Z naught. That is equals to S21. So this is your S21. Okay, S11 and S21 we have found. Now you can find S22 and S S22 and S12. S22 and S12. For that, we already know V1 plus, V1 minus, V2 plus, V2 minus. What I need to keep equals to 0, that is V1 plus equals to 0. So I will match the port 1. Okay, this was your V2 and this is your V1. If I match the port 1, then what is going to happen? V1 plus will be equals to 0 and this complete transmission line can be replaced with Z0. So what you are getting? This complete transmission line will be replaced with Z0. This is your Z. This is your again transmission line. This is your again transmission line. This is your transmission line. Okay. On this transmission line, what you are having? V2 plus is incident and V2 minus is reflected. Okay. This is your V2 and this is your V1. Is that clear to you? So what I need to find? S22. S22 is equals to V2 minus divided by V2 plus with what? With the V1 plus is equals to 0. And what is this? This is the reflection coefficient at load. And what is the reflection coefficient at load? Z parallel with Z0, ZL minus Z0. It is having intrinsic impedance of Z0. So ZL minus Z0 upon ZL plus Z0. So exactly the same calculation here what we did, the same calculation we are getting. So what will be the value of S22? S22 will be equals to minus Z0 upon 2Z plus Z0. Minus Z0 upon 2Z plus Z0. That will be S22. Okay. Now what about S1? S22 is there, S12 I need to find. So what is S12 equals to? S12 is equals to V1 minus divided by V2 plus, when V1 plus is equals to 0. So here what I can see is that V1 is equals to V2, but V1 is equals to only V1 minus, because V1 plus is 0, and V2 is equals to V2 minus plus V2 plus. Okay, what I need to find? V1 minus divided by V2 plus. So if I divide by V2 plus, then what I'm gonna get? V2 minus divided by V2 plus and plus 1. Do I know the value of this one? Yes. What I need to find? This value. What this is equals to? S12. And when I put the value of this one, what I'm gonna get? Minus Z0 upon 2Z plus Z0 plus 1. So what you are getting? S12 equals to the same thing that you got previously. What you got? 2Z upon 2Z plus Z0. This you got 2Z upon 2Z plus Z0. Okay. So this is the scattering parameter. Minus Z0 upon 2Z plus Z0. Minus Z0 upon 2Z plus Z0. That is equals to S11 and S22. And S12 and S21 are also equal. Is that clear to you? Okay. So for series and shunt, we have seen S parameters. Let's see for more. Let's see for this one. So this is a different kind of network is given. Now T network is given. Okay. So for T network, 8.56, 8.56, all these are standard question. These are mentioned in the standard book. So this is your network now. These are the two transmission line. Both are having intrinsic impedance of 50 ohm. Here we will put the values now. Now we will solve with respect to values. Here we were putting Z node, but here we will put the values, and then you need to find S parameter of the particular network. So again you can try. Certainly you can try it, and you will be getting the results for sure. I remember the answer for this. The answer is this. If you are able to get answer, there is no doubt you can skip the complete discussion. If you are able to get this answer, you can skip the complete discussion. Okay. because like there will be no, what do we say, there will be nothing new in this one. The same manner we will be solving, but as an educator, this is an online class, so I have to solve it. Okay. The thing is, between V1 and V2 you need to play. What will be your V1? This will be your V1 and this will be your V2. So between V1 and V2 you need to play something. If you are able to play that, then it's cakewalk. Okay. So yeah, try doing it on your own. Again, I need to take a break because I'm not feeling well. So, but let's do the formalities that here V1 plus would come, V1 minus will be reflected, here V2 plus would come, and V2 minus will be reflected back. Okay. So V1, V2 I need to write down. V1, V2 I know what is V1. V1 is V1 plus plus V1 minus, and what is V2? V2 is V2 plus plus V2 minus. So let's not take a break. Let's start solving it only. So what I need to find first, S11 and S21. Good that I have made the diagram already. So I need to find S11 and S21 first. S11 and S21. For that, what I need to do, V2 plus is equals to 0. So if I need to put V2 plus equals to 0, that means this load should be matched here. This load should be matched here. Right? And if this load is matched, what does that mean? From here, input impedance will be equals to 50 ohm. Right? And do not forget to mark your V2 and V1. This is your V2, this is your V1. And here if I am marking, this is my V1 plus and this is my V1 minus. Right? So now this much will be replaced with 50 ohm. Okay. So I can copy this diagram. What else I can remove? This I can remove. Yeah, rest everything is fine. So here I will get 50. Okay, and this was your V2. This was your V2. So here what is the load? This is the load. This is the load, right? ZL minus Z0 upon ZL plus Z0. So what is the equivalent of this load? What is the equivalent of this load? You can calculate it. You will get to know it is 50 ohm. Okay. If you calculate the equivalent here, what I am writing, ZL equivalent. How will you calculate the equivalent? 50 plus 8.56, that is 58.56. 58.56 parallel with 144.8, that will come out to be 42.44. Okay, that will come out to be 42.44. 42.44. No, this will come out to be 41.44 actually. 41.44. So 41.44 plus 8.56 will be equals to 50 ohm. So this will come out to be 50 ohm only. Okay. So what do you see? What is your V1 minus divided by V1 plus? Certainly when V2 plus is equals to 0, which is equals to S11, and that is equals to ZL minus Z0 upon ZL plus Z0. So 50 minus 50 upon 50 plus 50. So what you are getting? 0. So S11 is coming out to be 0. Is that clear to you? S11 is 0. Now what else do you know? Now you need to find the relation between V1 and V2. Can you solve it with respect to network analysis? Yes. What I need to find? V2 in terms of V1. So how I can find it? What will be your V2? So first you will find the equivalent of this one. What is the equivalent of this one? 141.8 parallel with 58.56. What will be the equivalent? That will be 41.44. So from here equivalent would be coming 41.44. So what you will write? V2 is equals to 41.44 divided by 50. So here you will get the potential. Now this potential, whatever the potential you are getting here, that will be divided between 50 and 8.56. So into 50 divided by 8.56. क्या कर रहा हूँ मैं ये? Sorry, divided by 50 upon 58.56. Yeah, that's what I was thinking. Into V1. So that will be relation between V1 and V2. Look, this is simple network analysis, nothing else. Like if you are studying EMFT, then certainly you would know at least this thing. Otherwise, you are not going to write ECE question paper. So let's solve it. As far as I remember, it was coming out to be 0.707 only. I don't have the mobile. So it would come out to be 0.70 only. Okay, here you can see as well. This is roughly around 40. This is 60. So 40 divided by 60. So 0.66. Yeah, 0.707 only it will come. So V2 is equals to 0.707 V1. Okay. Now, do I need another page or here only I can solve? Here only I can solve. This is what we are getting. V2 is equals to 0.707 V1. Okay. Now, what is V2 equals to? V2 is equals to V2 minus only 0.707. Now, what is V1 equals to? Look, reflection coefficient is coming out to be 0, no? That means V1 minus divided by V1 plus is coming out to be 0. That means V1 minus is 0. There is no reflection. If reflection coefficient is 0, that means this is 0. There is no reflection, only incident wave is there. So towards the load, only V1 plus goes. V1 minus is not even returning. Why is that so? Because reflection coefficient is 0. So that means V1 is also equals to only V1 plus. Are you getting this point? So what is the ratio? What is S21? S21 is V2 minus divided by V1 plus when your V2 plus is equals to 0. When your V2 plus is equals to 0. S21 is V2 minus divided by V1 plus when V2 plus is equals to 0. Right? So what is the ratio of V2 minus divided by V1 plus? That is equals to S21 and it is coming out to be 0.707. There you go. Is that fine for you? Okay. So S11 is 0, S21 is 0.707. Similar manner, ditto same manner you need to solve for S22 and S12. So for S22 and S12 we need to solve. So let's keep it a bit downward. So here I'm gonna keep my V1 plus is equals to 0. If I keep my V1 plus equals to 0, that means this should be terminated with 50 ohm. And if it is terminated with 50 ohm, that means this will be replaced with 50 ohm. Okay. So this you can do on your own very easily. So this much part here, this impedance will be gone and it will be replaced with 50 ohm. Okay. Certainly this will be your V1 and this will be your V2. Right. So ditto same expression, everything is ditto same, nothing else. So what is your S22? S22 is defined as V2 minus divided by V2 plus. When you calculate the equivalent of this, what this come out to be? 50 ohm only. So V2 minus divided by V2 plus, but when V1 plus is equal to 0. So ZL minus Z0 upon ZL plus Z0. So 50 minus 50 upon 50 plus 50, that is equals to 0 only. So S22 is 0. And what is the relation between V1 and V2? So V1 will be equals to 0.707 into V2. And what is V1? V1 is simply V1 minus only. And what about V2? V2 is also equals to only V2 plus. Why is that so? Because here I can see that S22 is V2 minus divided by V2 plus. So V2 minus will be equals to 0 only. So this is the scene. So what you are getting, S12 is coming out to be 0.707. There you go. Okay. So what is your scattering parameter? This is your scattering parameter. 0.707, 0.707, 0.707 and 0. It was an easy question. Just between V1 and V2 you need to play. Otherwise it was a cakewalk for you because we have solved two kind of problems like that. Now we can find this S parameter for transformer as well. Okay. For this transformer. So I will see whether we will see it in this video or we can see it in assignment as well. Like I can frame an assignment problem and there we can solve it. I will just give you this transformer. This is the transformer. Now this is your two-port network. There are two transmission lines connected here. One transmission line, two transmission lines are connected here. This is having N1 turn. This is having N2 turn. Now for this transformer, you find the S parameters. This is having some Z node impedance, this is also having some Z node impedance. You find it. Okay, you can try it on your own. Okay. We will see it in assignment, or in the last of this video we can solve it. That I need to check whether we will see it in assignment or in the last. Now let's solve a problem on Z parameter. I will relate it with S parameter. What I am gonna do that you will understand, but I will relate it with Z parameter. Sorry, I will relate it with the S parameter. So what I need to find? I need to find Z in. What is my Z in? Z in is V1 by I1. Right? Z in is V1 by I1. On any port, if I need to find impedance, let's just say this is some network, and if I need to find input impedance here, what do? I apply some test voltage and get some current out of it, and that Zx will be Vx by Ix, right? Similar thing we are going to do here. This was some network, and I needed to find Z in impedance here, so I applied a voltage V1 and get I1 out of it. V1 by I1 will be my Z in, right? V1 is equals to Z11 I1 plus Z12 I2, V2 is equals to Z21 I1 plus Z22 I2. Okay. Now here what do I see is that I2 is equals to, this I2 current is flowing here as well. No? So V2 is equals to minus I2 into R. So what I can do is that V2 is equals to minus I2 into R I can replace. Why I am solving this problem? These kind of problems you would have certainly solved in your network analysis, but why I am solving it, you will realize it. Okay. Certainly you will realize why I am solving it. Now what I am going to do is that I am going to replace this I2. I just need to replace this I2 with I1. That's why I am doing all these things. So I1 I need to replace. So how I will replace it? So minus Z21 I1 is equals to Z22 plus R into I2. So I2 is equals to Z21 minus Z21 upon Z22 plus R. Okay, this is your I2. Now this I2 I can put here. So what is the value of V1? V1 is Z11 I1 minus Z12, because I2 is negative, so Z21 divided by, certainly into I1 is also there, divided by Z22 plus R into I1. So what is V1 by I1 you are getting, which is equals to Z in, that is V1 by I1, that you are getting as Z11 minus Z12 into Z21 upon Z22 plus R. So this is Z in I am getting. So this is how we find it, right? Okay, so we are calling it as input impedance, right? Can I call it in this manner, that this is your new Z11 parameter for the one port network shown? What did I say? This Z in is your new Z11 parameter, for the one port network, What do I mean by that? Is this a two port network or is this a one port network? What do I mean by two port? That this is a network. So here also I can apply some potential, and here also I can apply some potential. From here I get I2 current, here I get I1 current. So this is known as two port. But here what I am doing, I am just connecting a resistor here. So now I cannot apply here some potential, right? Are you getting this point? So this has become a one port network now. Let's just say if this was some T network, assuming that this was some T network, then the other end of this T network is connected to some R. This were R1, R2, R3. This port was R1, R2, R3. Then here you are connecting R. Now what you are doing? You are applying some V1 here and getting I1 out of it, and then you are calculating Z in. So this is a one port network only. No, this is not two port. Here you cannot say that I am applying V2 here and getting I2 out of it. This is not your V2 I2. This is your V2 and this is your I2. And V2 I2 is solely function of I1. I2 is solely a function of I1. Are you getting this point? Now this has become one port network. Like this is simple network analysis that I am talking about. So it is like a new Z11 parameter. What is Z11? V1 by I1. But it has a condition that your I2 is equals to 0. Then you get no Z11. Z11 is Z11, what is your Z11? Z11 is V1 by I1, but the condition that I2 is equals to 0. So I can, for just saying purpose, I can call this one as Z11 new Z11 parameter for the one port network shown. This term you might not have heard in network analysis, but this kind of questions was asked in your gate examination. What was asked? Let me show you. Okay. So what was asked here? What did I do? I just found V1 by I1, and that V1 by I1 that I got, that I am calling as new Z11 for the one port network shown. Why one port? Because this has become a one port now. So similar, the same language was asked in gate 2014. That a two port network is shown, which was not shown actually. So for a two port network, this was the scattering parameter. So there is a two port network, for that this was the scattering parameter S11, S12, S21 and S22. If the port 2 of the two port is short circuited, if this is the second port which is short circuited, certainly this will be a transmission line. So here load is shorted. Here the load is shorted. Then the S11 parameter of the resultant one port network is. That means what they are asking. What is your S11 parameter? S11 parameter of the resultant one port network. What they are asking, that you are sending V1 plus from here, receiving V1 minus from here. So how do you define S11? S11 I define V1 minus divided by V1 plus. But for the new circuit, which new circuit? In the new circuit where your load is shorted. Here what did I do? This was my simple two port network, but I replaced the load with R. Now I was asking input impedance, but that input impedance, what gate examination is calling? What that input impedance gate examination is calling? The gate examination is calling that input impedance as new Z11 parameter for the one port network shown. Similarly, here they were saying that you need to find new S11 parameter for the resultant one port network shown. This I need to find. So I need to find this ratio V1 minus divided by V1 plus. But now I cannot keep V2 plus equals to 0. Here I did not do that V2 is equals to 0. For finding Z in, I did not do I2 is equals to 0. Here I found I2 in terms of V2 and then I replaced it and then I got this expression. So certainly in this one as well, I cannot keep V2 minus. How do I define S11? For a scattering parameter, how do I define S11? S11 I define as V1 minus divided by V1 plus when V2 plus is equals to 0. But now I am not going to put V2 plus equals to 0 because load is not matched now. Load is shorted. So they have connected the load in their own way. They already have connected the load in their own way. And for me, what could be the better way of asking this question was, they could have simply told that tell me the reflection coefficient here. Look, this new S11 parameter for the one port network, this doesn't seem like a perfect language for me, right? But what they want to ask, V1 minus upon V1 plus. So what they are asking, reflection coefficient only. So they could have told that what is the reflection coefficient at input port. Here what do they ask? What is the input impedance at the input port? So same thing they could have asked, what is the reflection coefficient at input port? So this is what they are asking, gamma in they are asking. Are you understanding that why did I pick this question? Just to make you understand that what gate examination wanted to ask here. It might seem like that, sir, what is this S11 new parameter for one port network? Yeah, but this is what they asked. This was the language of gate 2014 gate examination. Okay, so this might be the case that this is how it is called, that new S11 parameter for the resultant one port network. So this S11 parameter only we need to find. Okay, so that we will do, but I hope till now you must have understood the meaning of the problem, that what they are going to ask. They are just asking the V1 minus divided by V1 plus, but now you cannot put V2 plus equals to 0. This you cannot do. Okay, so what you are gonna do, simply over here I will just make it that they are asking gamma in only. Okay, and this is your V2 plus is being incident and V2 minus is reflected back. This is what we do, right? Okay, fine. So now first I will define, whenever there is a problem on scattering parameter, your first task would be, or not just scattering parameter, whenever there is a problem on S parameter or H parameter, G parameter, Z parameter, Y parameter, always write the definition. What is the definition? This is the definition. Your half job will be done here. Like a lot of students don't even write the definition and they keep on solving the problem that S11 is equal to V1 minus upon V1 plus when V2 plus is equal to 0. No, first write the definition. Things will come to you once you write the definition. S21 V1 plus S22 V2 plus. Okay. So this is your V1 minus and V2 minus. Now here, can you let me know this load is this, let's just say this was having some intrinsic impedance Z naught. No, sorry, not intrinsic impedance. This was having some characteristic impedance Z naught. We are assuming it. Okay. Now load is shorted. So can you let me know the value of V2 minus divided by V2 plus? V2 minus divided by V2 plus. What will be V2 minus divided by V2 plus? For this load, for this short circuit load, V2 minus is the incident wave and V2 plus is the reflected wave. So if I write down the reflection coefficient at port 2, if I write down the reflection coefficient, what that would be? Think about it and let me know whether it would be V2 minus divided by V2 plus or it would be V2 plus divided by V2 minus. What do you think? It would be V2 plus divided by V2 minus. Why is that so? Because V2 minus is the incident wave for this load and V2 plus is the reflected wave for this load. So this gamma will be equals to V2 plus divided by V2 minus, and what that would be equals to? ZL is 0, ZL minus Z naught upon ZL plus Z naught. This intrinsic impedance I am calling as Z naught 2. So what this is coming out to be? Minus 1. So what you are getting? V2 plus divided by V2 minus is equals to minus 1. So what you are getting from here? V2 plus is equals to minus V2 minus. What I need to find, what is my target? What will be my S11 new? That would be equals to V1 minus upon V1 plus. So here my target is that this V2 plus should be gone. My target is that V2 plus should be gone. So here in this equation, what I am going to do is that this is my equation 1, this is my equation 2, and this is my equation 3. So from equation 2 and 3, ditto same thing I was doing in Z parameter rule as well. That I was finding a relation between V2 and 2, then I was replacing it, then this kind of calculation I was doing. Same thing I am going to do here as well from equation 2 and 3. So V2 minus I am replacing as minus V2 plus is equals to S21 V1 plus S22 V2 plus. So minus S21 V1 plus is equals to 1 plus S22 V2 plus. Need to add a page. So what you are getting? V2 plus is equals to, because I need to replace V2 plus only, so I will find V2 plus is equals to minus S21 V1 plus divided by 1 plus S22. Okay. Now I will replace this V2 plus in equation 1. So from equation 1, V1 minus is equals to S11 V1 plus V1 minus is equals to S11 V1 plus S12 into V2 plus. What is the value of V2 plus? V2 plus is minus S21 upon 1 plus S22 into V1 plus. So what is the value of V1 minus divided by V1 plus you are getting? That you are getting as S11 minus S12 S21 upon 1 plus S22. So what is this? This is your S11 new, which is equals to S11. Now this I am cross multiplying, plus S11 S22 minus S12 S21 divided by 1 plus S22. There you go. This is your S11 new. So this was mentioned in one of the option and that was correct. So this is how you needed to solve. Did you understand what they wanted to ask? Okay, so this was a bit like language was a bit different, but what they wanted to ask, they just wanted to ask the gamma in here, nothing else. And what is your gamma in? V1 minus upon V1 plus. This is what they wanted to ask. Okay. Now let's take a general case. Here short circuit load was there, no? Here the load was short circuited. Load was shorted. But what if there is some load ZL? What if there is some load ZL? So I am defining my gamma load here. What I am defining? Gamma load. What that would be? ZL minus Z naught upon ZL plus Z naught. In the previous case, it was coming out to be -1. Here it was coming out to be -1. But it's not necessary that always they will give short circuit. They can give anything there, right? If they can give anything. So what this gamma load will be equals to? This gamma load will be equals to the reflected wave, which is V2 plus, divided by the incident wave, which is V2 minus. What we are finding? We are finding gamma in here. What is your gamma in? Gamma in will be here. Gamma in will be, this is the incident. Sorry, yeah, reflected by incident. So reflected is V1 minus divided by V1 plus. So this is what we are finding. V1 minus divided by V1 plus. You can call it S11 new as well. Okay. You can call it S11 new as well. So this is what we are finding. So for general case, we are seeing it. So this is equals to gamma load. So from here, V2 plus is equals to gamma load V2 minus. But that I don't need to write. I need to write V2 minus is equals to, because first I need to replace V2 minus. So V2 minus is equals to V2 plus divided by gamma load. Okay. So do you know the equation of V1 minus and V1 plus? V1 minus is equals to S11 V1 plus S12 V2 plus, and V2 minus is equals to S21 V1 plus S22 V2 plus. Okay. Now this is your equation 1, this is your equation 2, and this is your equation 3. This analysis you should be doing on your own. Nothing else. There is nothing, just simple mathematics is there. So from 2 and 3. V2 plus divided by gamma load. V2 minus is equals to V2 plus divided by gamma load is equals to what? S21 V1 plus S21 V1 plus S22 V2 plus. Okay. What I need to replace? I need to replace V2 plus. So I will take V2 plus aside. So what we are getting? 1 by gamma load minus S22 S21 V1 plus. Okay. So what we are getting? V2 plus is equals to S21 gamma load S21 gamma load divided by 1 minus S22 gamma load is equals to V1 plus. So this is new expression we are getting. Now using equation 1. If I use equation 1, there I am gonna put what I am gonna put. V1 minus is equals to S11 V1 plus S12 V2 plus. But S12 V2 plus, in place of V2 plus, what I am gonna put? I am gonna put this much thing, that is S21 gamma load divided by 1 minus S22 gamma load into V1 plus. So what you are getting? S11 new you can say, or you can say gamma in you can say, or what you can say, or you can say V1 minus divided by V1 plus. Whatever you want to call it, you can call it, and that you are getting as S11 plus S12 into S21 divided by 1 minus S22 gamma load. There you go. This expression you are getting. In the previous case, and sorry, here also there is gamma load. So this expression you are getting. Let me check if calculations are correct or not. So S11 plus S12 S21 gamma load 1 minus S22 gamma load. Yeah. So this is the answer we are getting. So any kind of load they can give. Any kind of load they can give. First you will find gamma load, then you will find this relation and you will put here. So this final answer you don't need to mug it up. Do you remember the Z in formula? Do you remember this Z in formula? No. We can calculate it, no? If in the examination. So in the examination they will give any random load. Just like here they gave short circuit. So if you remember the formula, then you can put directly -1 here, because gamma load was -1. If you put -1, you will get the same answer. Okay, but certainly we are not going to remember the formula, right? If I put gamma 1, will I get the same answer only? Gamma load was -1 there, right? Gamma load was -1. So if I put gamma load equals to -1 here, here also -1 would come. So S22, you can check, I guess same answer would be there. Okay, it will be +1. So S11 plus S12 minus, yeah, same answer would be there. Okay, just put gamma load equals to -1, you will get the same answer, because this is just the more general case. Okay, so any case they can ask in the examination, they can give any random load and they can ask you to calculate this particular thing. So if they are asking new S11 parameter, then you would know what they want to ask. Is that clear to you? Okay, fine. Now some scattering parameters properties we are going to see. Properties. Okay, so let me take a break, then we will see the properties. Now I need a break. Okay, so we will see the properties after a break. Scattering parameters properties. Very simple. In just 20 to 25 minutes we will complete this particular chapter. Not per chapter, sorry, this particular topic. Okay. Okay, now let's start and we will see the scattering parameters properties of scattering parameters. So this was our two-port network whose scattering parameters were defined S11, S12, S21, S22. These were our transmission line. V1 plus we were sending, V1 1 minus was being reflected back, and V2 plus we were sending and V2 minus was being reflected back. Then this is how V1 minus and V2 minus were defined. Now can I write down V2 minus and V1 minus as a matrix as well? This is how I can write it down, right? V1 minus is equals to S11 V1 plus S12 V2 plus, V2 minus is equals to S21 V1 plus S22 V2 plus. Simple mathematics. So this is our scattering parameter matrix. So this is our matrix. Now based on this matrix, there are some properties of scattering parameters. What are those properties? Like in Z parameters, in Y parameters, in G parameter, in H parameter, we used to study there is reciprocal network, there is symmetric network. So similarly, there is property of this scattering parameter. What is the property? Now it's not necessary that scattering parameter is defined for only two port. What I mean to say is that this is a port, so it can have multiple ports. So scattering parameter can be defined for multiple ports, okay, not only for two ports. Are you getting this point? So, but the thing is, always this matrix, scattering matrix I am saying, or scattering parameter matrix, this will be always a square matrix. That means S12, S1, S11, S12, S13, S21, S22, S23, S31, S32, S33. So always it will be a square matrix of n cross n order. This is the first property. What is the property? What I am saying is that scattering parameter is need not necessary that it will be like this only. That we were getting different answer. Here we were getting 2 cross 2 matrix. So it is not necessary that you will be getting 2 cross 2 matrix only. You can get 3 cross 3 as well, 4 cross 4 as well. It depends on the number of ports. Okay, but always it will be a square matrix. Secondly, now a network will be called reciprocal if this scattering parameters matrix is equals to its transpose. Do you know what is transpose? 1, 2, 3, 4, 5, 6, 7, 8, 9. How do you calculate the transpose? Just rows will be made column 1, 2, 3, 4, 5, 6, 7, 8, 9. This is how you calculate the transpose. So it is known as reciprocal if the transpose and the matrix are equal. Is that clear to you? Now the network is known to be lossless if you multiply the scattering parameter matrix into, you calculate the conjugate of the scattering parameter and then you take the transpose. What you are doing, you are calculating the, you are having the scattering parameters, okay, you are having the scattering parameter matrix. Then what do? You take the conjugate of all these elements, then you take the transpose, and once you multiply both of them, it should be equals to your identity matrix. Are you getting this point? Two properties you need to remember: reciprocal and lossless. Reciprocal means S should be equals to S transpose, and lossless means S into S conjugate transpose is equals to your identity matrix. What is identity matrix? That all the diagonal elements should be 1, rest all should be 0. This is known as identity matrix, right? Is that clear to you? Now a network is known to be matched at all ports. What do you mean by matching? Matching means reflection coefficient should be 0. And what is denoted by reflection coefficient? S11. S11 was the reflection coefficient at port 1. S22 was the reflection coefficient at port 2. S33 would be reflection coefficient at port 3. S and N will be reflection coefficient at port N. So if it is matched, that means reflection coefficient is equal to 0. Are you getting this point? So a network is known to be matched if the S11, S22, S33, S44, S55, SNN is equal to 0. So these three things you need to keep in mind. Now let's talk about this lossless property more. Okay, a network is said to be lossless if S and the conjugate of that, and then you take the transpose, multiplication of both of them should be equal to identity matrix. So this is, let's just say this is your 3 cross 3. This is your 3 cross 3 scattering parameter matrix. Okay. Now what will be their conjugate? S11 conjugate, S12 conjugate, S13 conjugate, right? Now what I need to do? I need to take the conjugate and then I need to take the transpose. So I am taking the transpose, S12 conjugate, S13 conjugate, then S21 conjugate, S22 conjugate, sorry, S21, S22 conjugate, S23 conjugate, then S31 conjugate, S32 conjugate, S33 conjugate. Okay. So when I multiply both of them, it should be equal to identity matrix. So just do the multiplication. This and this will be multiplied, which should be equal to 1. So if I multiply both of them, what I am getting? S11 into S11 conjugate plus S12 into S12 conjugate plus S13 into S13 conjugate is equal to 1. Now what is S11 into S11 conjugate? That is S11 mod of S11 whole square. Like let's just say S11 is coming out to be 0.275. So what will be your S11 conjugate? That would be 0.2 and angle is minus 75 degree, right? Because if you take the conjugate, that means angle will be negative. Now if you multiply both of them, what you are going to get? 0.2 whole square into 75 degree minus 75 degree. So this angle will be 0. Now what is 0.2 whole square? 0.2 whole square is the S11 magnitude whole square, right? Are you getting this point? S11 was 0.2 angle 75. Now if I take the conjugate, that means I will be taking the negative angle. Magnitude remains the same. So 0.2 whole square I will be getting there. Okay. So that is equal to S11 S1 mod of S11 whole square, right? So this is equal to mod of S11 whole square. Similarly, this will be equal to S12 mod of S12 whole square, and this will be equal to S13 whole square. So if you can keep this in mind, then you can keep this in mind. Similarly, what else property you will get? That any row you can take, this row you can take, this row you can take, this row you can take. Just take the magnitude of all of them, square it, then add them and check whether you are getting the summation equals to 1 or not. If you are getting summation equals to 1, that means that will be a lossless network. Okay. So let's revise everything what we have studied. What we have studied is that there are some properties. S matrix would be a square matrix. It will be reciprocal if the transpose is equal to the matrix. It will be lossless if the matrix into the conjugate by after taking the transpose, or after, first I will take the conjugate, then I will take the transpose. If I do multiplication of both of them, then I will get the identity matrix. And if I elaborate it, then I get to know that you take any row, you take the mode of that, mode of S parameter of that row, S11 whole square, mode of S11 whole square plus mode S12 whole square plus mode S13 whole square. If you add all of them, it should be equal to 1 for lossless network. Okay. Then we talked about matched at all port. Matched means, matching means reflection coefficient should be 0. At port 1, what was the reflection coefficient? S11. At port 2, what would be the reflection coefficient? S22. Similarly, S33, S44. So if there is matching, that means all these should be equal to 0. Is that clear? Right? Then there is a term called return loss. What is the meaning of return loss? So anywhere if return loss is written, that means it is equal to minus 20 log tan mode of gamma. That's it. Okay. And certainly its unit will be dB. Let's just say they are saying that return loss of a transmission line is this one, this much. That means whatever the reflection coefficient of that transmission line is, then minus log tan and reflection coefficient. Let's just say reflection coefficient was 1/2. So its return loss is 20 log 10 to dB. This is known as return loss. So once the question was asked on this particular topic, that what do you mean by return loss? Okay, they mentioned the return loss and then they found then they asked the VSWR value. So if return loss is mentioned, I can find the mode of gamma, and if I can find the mode of gamma, then 1 plus mode of gamma divided by 1 minus mode of gamma is equal to VSWR. So this is what they asked. Okay. So I hope you know what do you mean by return loss. Let's solve a problem based on everything that we have studied regarding the properties, right? From here, whatever that we have studied, based on that we are solving this problem. So a certain two-port network is measured and following scattering parameter matrix is obtained. So this is the scattering parameter matrix. For the data, you need to determine whether the given network is reciprocal or lossless or matched at all ports. Now, this is the first question. The second question is, if a short circuit is placed on port 2, what will be the resulting return loss at port 1? So, two questions you need to solve. So, first let's answer the first one. So, let's study this matrix. If I study this matrix, what do I get to know? For reciprocal, what is the condition? For reciprocal, what is the condition? That S should be equals to S transpose. If I calculate S transpose, what I am getting? What is my S transpose? S transpose is 0.1 0 degree angle, then 0.8 90 degree angle, 0.8 90 degree angle, 0.2 0 degree angle. This is simply equals to S only, right? This is simply equals to S only. If you calculate the transpose, you are getting to know that it is equals to S only. That means it is reciprocal network. Okay, first one job is done. Now second is lossless. So for lossless, what you need to do? Pick any line. Pick any line. Mode of S11 whole square plus mode of S12 whole square. This you will calculate. Along with that, you will calculate S12 whole square plus S12. S11, S12, S21, S22. Okay, yeah. S21, S22. So mode of S11. What is the mode of S11? This is the angle, this is the mode. So 0.1 whole square plus 0.8 whole square. Mode is, this is the angle, this is the magnitude. So what you are getting? 0.01 plus 0.64. So you are getting 0.65, which is certainly not equals to 1. And if you do the second one, that is 0.8 square plus 0.2 square. 0.2 square is 0.8 square is 0.64 and 0.2 square is 0.04. That is equals to 0.68, which is not equals to 1. So certainly it is not lossless. Not lossless. Certainly there will be loss. And what about matched? Here you can see that S11 is not equals to 0 and S22 is certainly not equals to 0. That means reflection coefficients are finite. So certainly it is not matched. Not matched at all ports. Or you can say not matched at any port. Right? Not matched at any port. Because neither S11 is 0, neither S22 is 0. Okay, so three answers: not lossless, not matched at any port. Now let's solve the second one. Second one, what they are saying: if a short circuit is placed at port 2, this was your scattering parameter, this would have been your transmission line, and a short circuit is placed here, this would have been your port 1, and a short circuit is placed here. Then what will be the resulting return loss at port 1? So what you are supposed to find? Return loss at port 1. What is your return loss? Return loss at port 1, that would be equals to minus 20 log 10 mode of gamma. And what is mode of gamma? Reflection coefficient at port 1, right? Reflection coefficient at port 1. So what I need to find? So here for scattering parameters, what do we do? I send V1 plus, reflected back is V1 minus. I send V2 plus, reflected back is V2 minus, right? So what I need to find? If I need to find mode of gamma here, that means I need to find what is my reflected back? V1 minus upon V1 plus. But this is not with respect to any condition. Simply I need to find V1 minus divided by V1 plus. Nothing else. No condition that V2 plus is equal to 0. Here you are not finding S11. Here you are simply finding V1 minus divided by V1 plus. So how you can find it out? What do you know? You know your S parameters, or what do I know is that V1 minus is equal to S11 V1 plus S12 V2 plus, and V2 minus is equal to S21 V1 plus S22 V2 plus, right? Here what do I know is that short circuit load is there. That means what is the reflection coefficient here? What is the reflection coefficient here? Gamma load. Okay. What is the reflection coefficient here? That is -1. But that is at port 2. That is at port 2. So 2 I am writing. Reflection coefficient at port 2 is -1 because ZL is 0. So 0 minus Z0 upon 0 plus Z0, that is -1. And this is equals to what is the reflected wave? V2 plus divided by V2 minus. So that is equals to -1. So have we seen this kind of condition? Yes. We have solved this kind of condition, and what do we get? What is the value of V1 minus upon V1 plus? Here we have solved it, right? What do we get? This equation we are going to get. S11 is equals to S11 plus S11 S. What this is S11 new? This is equals to V1 minus upon V1 plus. No, same circuit is there. Did to same. The load is shorted. The load is shorted. Same thing we are doing. Are you getting this point? Now here I would have done the same thing. In this problem as well, I need to find this ratio. Then what I would have done, that I would put V2 minus equals to minus V2 plus. Then I would put it here. Then I would do the manipulation. Then I would put V2 plus here. Then I would get the value of V1 minus divided by V1 plus. And what that would be equals to? So that I need to check. 1122 minus 1221. 1122 minus 1221 divided by 1 plus S22, or plus or minus. From here only I will get to know whether it will be plus or minus, or directly let's check it. It is plus only. Okay. So do I have the values of all of them? What is the value of S11? Where is my matrix? This is my matrix. Value of S11. This is your S11, S11, S12, S21, S22. So S11 is 0.1 because angle is 0, so it is 0.1 only. So S11 is 0.1 plus again S11 is 0.1 only. What is the value of S22? Value of S22. S22 is 0.2 minus what is the value of S12? So this is your S12. This is your 0.8 J, right? Because 90-degree angle will result in J. So it is 0.8 J. And what is your S21? That is also 0.8 J. 0.8 J divided by 1 plus S22. S22 was this one, which is 0.2. So this is 0.1 plus 0.02. J into J is -1 plus 0.64 divided by 1.2. Right? This is 0.1. This is 2 by 100, 0.02. This is 8864 divided by 100. J into J minus J square minus 1 plus, yeah, okay, fine. So what we are getting is that 0.64 plus 0.12, right? 0.76 divided by 1.2, 0.633. So this is your mode of gamma at port 1. And what will be your return loss then? Then your return loss will be minus 20 log 10 into 0.633. So take the log 10 of it, log 10 into 20. So 3.96 we are getting. Is this correct? Yeah, 3.97 or 3.96. Return loss, not returns. Return loss. So return loss we are getting 3.97 dB. So this is the answer. Okay. This is the answer. So for return loss, you just need to calculate the reflection coefficient. Is that clear to you? Anywhere they can ask, on any transmission line, anywhere they can ask their return loss. So you just need to calculate the magnitude of reflection coefficient and then take this. Here we were not thinking that S11 is your reflection coefficient. No. What is your S11? S11 is actually V1 minus divided by V1 plus, but with the condition. But this is not they are asking. They are simply asking without any condition. Why without any condition? Because they have made your load as shorted. So now your V2 plus is not equals to 0. Your V2 plus is finite. So that V2 plus is finite. So that S11 you don't need to find. You need to find S11 new. So this calculation we have already done. Where we have done this calculation? Previously only. So calculations already done. Calculation already done. So that you remember it. When you revise this, you should remember that where you have done the calculation. So calculations already done. Is that clear to you? Okay. So yeah, that's it about scattering parameters. We can find scattering parameter of a transformer as well, but that we will find in the assignment video. So that will work as a question for you. Okay. You need to find scattering parameter of a ideal transformer. So that will work as a question for you. That we will solve in the assignments. So as of now, this is the end of scattering parameters. In the next video, we need to study about Smith chart. Okay. So that will be the final concept, Smith chart. So now before studying Smith chart, I would request you to revise first 4 lectures. In the first lecture, we were studying about transmission line equation. In the second, we were studying about the types of medium, lossless, lossy. In the third, we were studying about impedance calculation. In the fourth, we studied about standing wave pattern. So if you know all these things, all these 4 chapters, then only you will be able to understand Smith chart. Otherwise, nothing you are going to understand. So your complete transmission line will come on a circle, and that is known as your Smith chart. And that circle is drawn on complex gamma plane. So that complex gamma plane we will study. We will draw that circle, and then we will study about the transmission line only. So first 4 lecture you need to revise. I'm not asking you to watch the video again. You just need to revise it. Just revise the notes. Is that clear to you? Okay then. Yeah. Thank you very much. Let's start studying the Smith chart. Okay. Yeah. Thank you.